Hi everyone, my name is Thomas Kim. Today is July 29th, 2019. This is my 26th episode about graph in C++. In this episode, we will learn about C++ dynamic polymorphism. There are many literatures. There are quite a lot of text or descriptions about dynamic polymorphism. This is classic polymorphism in C++ programming. So I will not talk much about dynamic polymorphism, but I will give the most fundamentals. First, the base class should have a virtual destructor. Then all inherited classes will automatically have virtual destructor by default. We can test if a class has a virtual destructor by using std has virtual destructor vType function. If a class has a virtual destructor, the C++ compiler generates virtual function table. Y is called vTable. To create an entry in the virtual function table, we have to use keyword virtual. In the derived class, the keyword virtual is optional, but highly recommend to use override keyword. The classic dynamic polymorphism works using either reference or pointer types. To typecast from base class to derived classes or vice versa, we should use dynamic cast. If the type is reference type, dynamic cast throws std bad cast. If the type is a pointer type, dynamic cast returns null pointer when the cast fails. I will fix this part. In the derived classes, the keyword virtual is optional, but I highly recommend to use override keyword. For when using dynamic polymorphism, you should be especially careful of slicing problem. About slicing problem, please double-click this link and watch this video. If you don't understand the slicing problem and you use dynamic polymorphism, you are apt to leak memory resources. So understanding object slicing problem in C++, especially when you are using dynamic polymorphism, correctly understanding object slicing problem in C++ is important. Without further ado, let's get started. Start Visual Studio Code. Under CPP extension graph subfolder, click this button, 26 Dynamic Polymorphism. .cpp, hit enter. Ctrl V, include talkplay fun, output HPP, talkplay fun, SS stream, auto, ender, talkplay fun, ender. So I create a base class, base with virtual destructor, base with a virtual destructor, public virtual base with a virtual destructor, default. Okay, this is virtual destructor, class base without virtual destructor, public base without virtual destructor, default. So I created two base class. Base class with virtual destructor has a destructor marked with virtual. In this case, base without virtual destructor, it does not have virtual destructor because keyword virtual is not used in this case. Okay, here class A is derived from public base with a virtual destructor public. I create another class B public base without virtual destructor. Okay, public. So I created 4 class base with a virtual destructor, base without virtual destructor. A is derived from base with a virtual destructor. Class B is derived from base without virtual destructor. Void test virtual destructor int main. I call this function. We will first learn std is base of b type function. Okay, stream is a the base or a base of b. We can test like this. std is base of b is a. Please note this pop-up text. The first element is base, the second is derived. B and L. So it is testing if A is the base of B. Okay, we will test once again. Is base with a virtual destructor a base of A? We can test like this. Is base with BD the base of A? Stream is base without virtual destructor a base of B. std is base of B, base without virtual destructor base of B and L. Now I will copy this part once again. Is A base of base with BD? Then it should be modified like this. Is A base of with BD? Okay. Also I will copy once again. Is B a base of base without virtual destructor? Then base B base without virtual destructor. And we can now test another thing. Stream has a virtual destructor. std has virtual destructor and there I will copy once again. Has B a virtual destructor. Now we run this function. Start command prompt. We will be using Clang compiler version. Please note that I am using Clang compiler installed on Windows through MSys64 over MinGW 64-bit. In this case, I use Clang++, std, C++ 1726, dynamic, polymorphism, .cpp, hit enter, cls A. So please understand the configuration. Is A base of B? False, because A and B, class A is inherited from base with BD virtual destructor. B is inherited from base without virtual destructor. They are not related inheritance tree. So A is not a base of B. False. Is base with BD with virtual destructor a base of A? True, because A is inherited from base with virtual destructor. Is A a base of base with BD? False. Base without BD a base of B? True, because B is inherited from base without virtual destructor. Is B a base of base without BD? False. Has A a virtual destructor? We have not defined virtual destructor for A, but since base with BD has a virtual destructor, all inherited classes also have a virtual destructor. So class A gets a virtual destructor by default. So the result says, has A a virtual destructor? True. In case of B, this base class is without virtual destructor. This base class does not have virtual destructor, so has B a virtual destructor is false. I highly recommend you understand that this type function is base of B and has virtual destructor B. These two type functions, the inheritance relationship through virtual destructor. There are lots of literature about dynamic polymorphism, so I will not talk much about dynamic polymorphism. I will try to give you the most fundamental ideas about dynamic polymorphism. In next few episodes, I will talk more about dynamic polymorphism in C++ language. I will upload complete source code to my website, extension talkplayfun.com website. By the time you watch this video, you can click this link and download the complete source code. If you unzip the downloaded file, under CPP extension graph subfolder, you can find the complete source code of this episode. Please subscribe to my YouTube channel. Thank you for watching.